Hello and welcome. In this video, we will explore an important chapter in mathematical analysis, sequences of real numbers. I'm Dr. Darwish Farida, and I will guide you through the main idea step by step. Before we dive into definitions and examples, let's take a moment to understand what sequences really are and why they are so important in mathematics. A sequence is simply an ordered list of numbers. Each number has a position, first, second, third, and so on. But why do we care about sequences? They are the building blocks of calculus, limits, derivatives, integrals. They help us understand how value evolves step by step. They appear in real-life problems like population growth, interest rates, computer algorithms. In analysis, they help us approximate value and study functions deeply. Studying sequence helps us to predict, analyze, and solve more complex problems. What's this chapter about? In this chapter, we will learn what means for a sequence to be bounded, what means for a sequence to be convergent, infinite limits, monotonic sequences, and subsequences, Cauchy sequences, limit superior and limit inferior. Bounded sequences. A sequence is bounded if each term stays within a fixed range. They don't go too high or too low. Imagine a ball bouncing between two walls. It never goes beyond them. That's the idea of a bounded sequence. Convergent sequences. A sequence is convergent when its terms get closer and closer to a specific value, called the limit. As n increases, the terms approach this number. Example: let's consider the sequence defined by un equals 1 over n. That means u1 equals 1, u2 equals 1 half, u3 equals 1/3, u4 equals 1/4, and so on. Infinite limits, monotonic sequences, and subsequences. Infinite limits. Some sequences grow endlessly, becoming larger and larger. We say that tend to infinity. Example: un equals n. So u1 equals 1, u2 equals 2, u3 equals 3, u4 equals 4, and so on. As n increases, the value of un gets larger and larger. There is no number that the terms are approaching. They just keep growing. We say the sequence diverges to infinity. Monotonic sequences. These are sequences that always increase or always decrease. No turning back. Subsequences. If you take some of the term of a sequence, like every second or the third term, you got a new sequence, a subsequence. Example: let's say we take only the even terms from the sequence un equals n. That gives us 2, 4, 6, 8. This is a subsequence. and it's also monotonic because it always increases. Cauchy sequences. A Cauchy sequence is a sequence where the terms get closer and closer to each other. Even if you go far in the sequence, the difference between terms becomes very small. For example, 1, 1.5, 1.75, 1.875, 1.9375, the numbers are approaching each other. That's the idea of a Cauchy sequence. Limit superior and limit inferior. Even when a sequence doesn't converge, we can describe how it behaves using two ideas. Limit superior is the highest value the sequence approaches. Limit inferior is the lowest value it approaches. Example: let's take the sequence un equals -1 to the power of n. The terms are u1 equals -1, u2 equals 1, u3 equals -1, u4 equals 1, u5 equals -1. It keeps alternative between -1 and 1. Then, limit superior of un is 1, the largest value it reaches often. Limit inferior of un is -1, the smallest value it reaches often. Thank you! Don't forget to check the lesson and happy learning!